Okay, so this is now Mrs. Suderman, and we are on page 5 of 6 of your review packet. So number 24, it says you can use polyroots on your calculator to help graph the following polynomials, or you can solve it the way that I'm about to. So on 24a, we have x cubed minus x squared minus 9x plus 9, and whenever there are 4 terms, it's a good idea to see if it works by factoring by grouping. So you would group the first 2 terms together, you group everything in pairs. So then your GCF for this first part, your greatest common factor, is x squared. When you take that out, you'll be left with x minus 1. Do the same thing with the second part. Always take out the negative in the number that's in the front, so minus 9. And then when you take out the minus 9 from this second part of our cubic function, you'll be left with x minus 1. Then looking across, both parts have a GCF of x minus 1. So I take out the x minus 1. Then I'm left with the x squared in the front, and then the minus 9 for the second part. But that's a difference of perfect squares. So I'll have x minus 1, x plus 3, and x minus 3. So then if you remember to set each of these things equal to 0 and solve for x, this first one will get an x value of 1, and then you'll get, for the next one, negative 3, and then for the next one, positive 3. So we have 3 zeros for our function, which matches our degree. We have a cubic function of 3 at a power of 3, so then we have 3 zeros. Your y-intercept is always going to be this last number, this constant term without a variable sitting here at the end. So our y-intercept will be at 0, 9. So we'll want to start out by graphing our zeros. So we've got zeros at 1, 1 to positive 3, and 1 to negative 3. And then our y-intercept is at 0, 9, so that's up here. Okay, so this is a positive function. The leading coefficient is positive, so that means the right side will go up. And because the degree is odd, that means the left side will do the opposite and go down. So if it's an odd degree, the arrows go in the opposite direction. And then from that point, we just go through all of our points that we have on the graph, and there you go. Okay, but for 24b, we have x cubed plus x squared minus 10x plus 8. Given that x minus 1 is one of its factors, this one you still have 4 terms, but if you tried factoring by grouping, it wouldn't work. But because we know that x minus 1 is one of its factors, you could either do long division, and you can see that on your answer key, or you could do synthetic division. So this x minus 1 means I'll have a positive 1 right there. And then let me write down my coefficients, making sure I'm not skipping any exponents. So we have 1 x cubed plus 1 x squared minus 10 x plus 8. So then you draw your line, bring down the first term, so we have 1, and then multiply it. So 1 times 1, you get 1. Now add them together, you get 2. 2 times 1 is 2. Add it together, you get negative 8. Negative 8 times 1 is negative 8. Add it together, and you get 0. Because it told us that x minus 1 was one of its factors, we already knew that this remainder should be 0. So then this is 1 degree less than what we started with. So this is 1x squared plus 2x minus 8. So now I have x minus 1. I divided that out, and when I divided it out, I was left with x squared plus 2x minus 8. And then you think, does that factor? Is there anything that multiplies to negative 8 but adds to positive 2? And yes, we have x minus 1 times x plus 4 and x minus 2. So then if you set each of those factors equal to 0 and solve for x, for the first one, you'll get x equal to 1. Then you'll get x equal to negative 4, and then you'll get x equal to 2. Your y-intercept is your constant term sitting there at the end, so you'll have 0, 8. So plot the zeros on your graph at 1, 2, and then negative 1, 2, 3, 4. Your y-intercept is at 0, 8. Plot that point. Okay, so again, this one is positive, so that means the right side would go up. If it were negative, the right side would go down. The degree is odd, so the left side will do the opposite. If it had been even, the left side would have done the same thing as the right side. And then we just go through the points and connect them. And there's your graph. Again, looking at this next function, we have rational functions. So let's start graphing. So you have 1 over x minus 3 plus 1. Your vertical asymptote you can tell by looking at what's in your denominator here. And so then that would be the vertical asymptote. Set it equal to 0 and solve for x. You get x equals 3. For the horizontal asymptote, you look at this last number right here. So we went up 1. So remember that for your parent function, you have asymptotes at x equal to 0 and y equal to 0. And then your graph kind of does this sort of thing. So then if we've moved it, anything with the x, remember that's the left and right, and it'll be the opposite. So minus 3 means we went to the right 3, and then this plus 1 means we went up 1. So the asymptotes would do the same. The vertical went to the right 3, and the horizontal asymptote will go up 1, y equals 1. So then for the domain and range, it's going to be all real numbers except where our asymptote is, x will not equal 3. And then for the range, it's also going to be all real numbers except for where our asymptote is at y cannot be equal to 1. So if we want to graph this, our vertical asymptote is at x equals 3. So right there, I'm just going to put a squiggly line so you can see it. And then the horizontal asymptote at y equals 1. Okay? And then we're just going to roughly sketch these, and that's fine. So we'll have the points didn't get stretched at all. So we have 1 right there, and we can go like that, and then like that. So there's our function. Okay, and then for the next one, here we went to the left 1, we went down 3, but we also got reflected over the x-axis and stretched by 2. So then our vertical asymptote, so we went to the left 1, is going to be at x equals -1. Our horizontal asymptote is at y equals, because we went down 3, it's at -3. Our domain will be all real numbers except for x cannot be equal to -1, and then the range will be all real numbers except for that y cannot be equal to -3. So putting the asymptotes on the graph, so we have x equals -1, y equals 1 to -3. Okay, so if we had points that were, if you pretended like that were the new origin, at 1, 1, and -1, -1. That 1, 1, its y value will get multiplied by -2, so we'll now be down here. So it got flipped over there. Okay, and what used to be at -1, -1 is now at -1, +2. So it got flipped over there. Not the prettiest graphs. Okay, next section. Okay, this section is about variation and rational equations. So on number 26, you have the time t it takes a salesman to drive to a sales call varies inversely as the average speed r. It takes a salesman 4.75 hours driving at 50 miles per hour. So because we have this as varies inversely, so our first variable will be, inversely is y equals k over x. Okay, so if we have the time t varies, the k always goes after the equal sign, and it varies inversely as the average speed r, so that means the r will be in the bottom here. Okay, so what is the constant of variation k? Well, if we know that it takes 4.75 hours driving at 50 miles per hour, we'll have 4.75 equals k over 50, and then if you multiply both sides by 50, that'll leave you with k is equal to 237.5. So then to write the variation equation, that just means you're going to fill in this k value, but you're going to leave the t and the r there. So we'll have t equals, now we know that k is 237.5 over over r. So we just fill in the value for k. Then how long would it take to drive at 60 miles per hour? So we have t equals 237.5 over 60, and then when you divide that, you get 3.8 9583333, so 3.96 hours. On number 27, the lateral surface L of a cone, so there's our first variables, we'll have L equals, the K always goes after the equal sign, jointly as the radius of the base R and the slant height L. So we'll put times R times little l, okay? And so L equals 63 pi meters, square meters when R equals 3.5 meters and L equals 18. So it gives us an almost complete scenario here where we just have to find the value for K. So if L is 63 pi, we don't know what K is. We know that R is 3.5 and we know that L is 18. So if I just simplify that a little bit, I get 63 pi equals K times 63. So then if I just divide both sides by 63, I get that K equals pi. So now I know that L equals, my K value is pi, and then we have times R times little l. So find R to the nearest tenth when L equals 8 pi square meters. So there's filling that in. We're looking for R, and our little l is 5. So then here, if we divide both sides by pi and by 5, then you get R equals 8 over 5, or you could say that's 1.6. And that'd be meters. Okay, so for this part, we are going to be solving for x. So we've got some rational equations here. So what you want to do is look at, all right, so on this first one, I think what would cancel out this denominator, and that'd be an x, and what would cancel out this one by multiplying, and that would be a 7. And I have to multiply this one by 7x to cancel everything out. But I need all of these things on the top to match. Well, I've got a 7x here, so this has a 7, but it'll need an x, and this has an x, but it'll need a 7. So now I'm looking across the top. I will cancel out whatever matches, so the x's match, and then multiply whatever's left over. So I have 21. And then here the 7's cancel, so I'll have plus, multiply together what's left over, 5x equals, and then this one, the 7x's cancel, so I'm left with 2. So if I subtract 21 from both sides, I'll get 5x equals negative 19. So then x equals negative 19 over 5, or negative 3.8. Okay, on 28b, first of all, factor this denominator, so I have x plus 4 and x minus 4. And now I think, what do I need to multiply by to get rid of all of my denominators? So here I would need to multiply by both the x minus 4 and the x plus 4. This one would need an x plus 4, and this one would need the x minus 4. But I need all of the top parts here to look the same. So this one, I'll add on there an x plus 4. This one needs the x minus 4. And now all of the top things look the same, and I can start canceling things out. So cancel out whatever matches the x minus 4's match, and multiply whatever's left over. So I have 6 times x plus 4 distributed, so I'll get 6x plus 24. Here the x plus 4's cancel, so 1 times x minus 4, so I'll get plus x minus 4. And then here the whole thing will cancel out, so I'm just left with x. So 6x plus x, you get 7x, and 24 minus 4, you get 20. If you subtract the 7x over, you'll get 20 equals negative 6x. Divide both sides by negative 6, and then you get x equals 20 over negative 6 reduces to negative 10 thirds, or you could say negative 3.33. And now for the multiple choice section. 29, in the diagram below, the plane y is perpendicular to the axis of the cone z. So this dashed vertical line here, that's our axis. And then this plane is perpendicular to the axis of the cone z. So whenever it slices through it, it's going to make a circle. On number 30, identify the conic section that the equation 2x squared plus 12x minus 3y squared plus 50 equals 0 represents. So if you look, we've got to only look at the x squared and the y squared terms. You only have to look at these two terms right here. These two numbers are different numbers and we have different signs. So when that happens, anytime you have a different sign, that means you're going to have a hyperbola. So this is a hyperbola. On number 31, we're going to identify this conic section. So all you have to do is look at the squared terms. So we have 2x squared plus 2y squared. Whenever you have the same sign and it's the same coefficient, the same number, so these are both positive 2, think that's the same all the way around, so that would be a circle. On number 32, in the diagram below, the plane J is neither parallel nor perpendicular to the cone K. So that means whenever this plane slices through the cone, it's going to come in at an angle here, and it will make an ellipse. On number 33, identify this conic section. Looking across for the squared terms, we only have one squared term. And so anytime there's only one squared term, that means you're going to have a parabola. Number 34, looking for the squared terms, we have a 4x squared and a plus 8y squared. They're different numbers, but they have the same sign. That means that this will be an ellipse. For number 35, in the diagram below, plane M is parallel to the axis of the cone A. So whenever this plane moves over, you'll end up seeing something like that, which is going to be a hyperbola. And then number 36, in the diagram below, plane M is parallel to the surface of the cone A. So plane M is parallel to the surface of the cone A. As cone A and plane M extend indefinitely into space, they will eventually intersect, which conic section will be formed. Whoops. And we're back. Whenever they intersect, when it's parallel to this outside edge, that is going to create a parabola. Okay, you've made it to the end. Good luck on your finals, and I hope you've had a good year in Algebra 2. Thanks for watching. Bye.